Hello. First of all, I would like to express uh, really great thanks to the organizers, to all volunteers who made a really great DevFest last several years. I participated in all of them, and every time it was really great. And this is one of the best DevFest that I ever participated. Thank you. And I would like to start a little bit about myself. My name is Valentyn Shybanov. As already mentioned, I am currently working in Amazon in an Alexa unit about natural language understanding. And my talk about how to make a scaling right. In a previous talk, Murat gave a really good presentation about Google Home and Google Assistant. Now, I would like to share my experience how the systems like Google Home, that in Amazon called Alexa, is designed, and what is the main principles of building the applications that can be scaled to the millions of the users that can use this all over the world, 24 hours a day, and all of these customers should never even notice about that there's other people are using, so they just want to use it. And to do this right, you need to not only think about the technical part of their scaling or your application, but also about the users and what are they expecting? What is the process of designing your application? Technical part, user experience, visual, audio, and that's a lot of things. But of course, one of the main thing is a technical. And when you start approaching this problem, you have a lot of questions to answer. For example, should you use a monolithic application, serverless? Which storage? What maybe cloud provider? Should you use Amazon? Should you use Google? Should you use Azure? Microsoft Azure, and a lot of other questions. What I would like to talk about is how to approach these questions, what you need to think about the scale when you start thinking about scalable application. Also, I will share about how this question is approached in Amazon itself. Also, I would like to say a small disclaimer. All information here would be only my personal. I don't represent Amazon opinion or Amazon as a company. So all information is available in the public, and this presentation is also available in GitHub. Later we'll get links. So first, why the question of scaling is important, why you should think about that, why just not to write an application, publish it, and just take a look what will be next. The question is because your customers really care about this, because when users see application, they don't know about are you using serverless, are you using monolithic, what storage, they just want to use it. And here I will give a couple of feedbacks that we got when sometimes it can happen that even Alexa can be down. So what is the impact of our customers? Here are other feedbacks, mostly not edited, so it's a raw. There are. Here you can see that there are some guy couldn't even turn lights. So no music in the bus. It was just really bad customer experience. It's also interesting because person cannot know about what weather is, how to turn on. Already forgot about how to turn on kettle, and how to turn on music. There's also interesting feedback. That user, for example, he wants to teach his family how to use Alexa. Always, and just taped all switches on position and asked family to use Alexa. But Alexa was down, so nobody can turn off the light. Sometimes this happens. this is an opinion about the interesting kind of specific feature of Alexa. It stores all alarms locally in the device, but when you try to turn it off, it tried to process this these utterance, and it was not possible to turn it off. Even if you unplug the Alexa device and then put it back, it starts alarming. So and this feedback is one of my favorite because it's expressed. I will read it. I didn't realize how helpless it became without Alexa. I cannot set alarm, can't play sleep time music, can't check and see if dog been fed, can't turn off the bedroom lights without using the wall switch, can't turn off TV without finding the remote that kid buried in one of the sofas, can set timer cooking the dog breakfast, can make the phone call from landline. Should I call 911? So it showed how important it is to have a really consistent system that should theoretically never be down. And in Amazon, we really try to take care seriously, mostly any feedback that you post or say or express. So we try to approach to the scaling very seriously. Okay, so you decided to think about the scaling. The first thing, question that you should ask about how seriously you should think about. Should you think about 2x spike, so 2 more users are using your service, or 5 times, or 10 times more? To answer the question, I will show you another graph. Anyone knows such game as a Pokemon Go? At least heard some time ago. So this is a graph how a company that created Pokemon Go decided to approach this question. So they calculated something like a target traffic. You see, it's a lower orange line. Then they said, okay, we should expect much more. Let's think about 5 times more traffic. When they launched, you see the green line. Mostly immediately it comes about the even worst case estimate. That means that when you think about design, you should not limit only 5 times, 10 times. You should think potentially how your system behave in a 50 times more or something like that. So another question that you can ask about, okay, we are not Google, we are not Amazon, we are a small company or small service, we are just startup. Should we care about this? Or even if yes, why we should care about this? The answer is that even if you are a small startup or the company that has not such a big audience as Google or Facebook or Amazon, you can save a lot of money if you think about the scaling from the beginning of the design of your product. So you can be really frugal and save a lot of money from the start where you don't have money. So it's a really good reason to think about the scaling and how to do it right. Okay, now let's think about how to make decision. How to make a right decision about the scaling. There are a lot of currently buzzwords like serverless, like microservices, like different storage. Should you use a scalable NoSQL or SQL service storage and so on. I would like to suggest you to imagine that we are trying to approach this problem, and now we will do it in Amazonian style. And in Amazon there is such principle as called working backwards. That's instead of just standing in a start position when you are and thinking about the possible best possible option where to go, you start in different opposite direction. You go to the end point where you already imagine that you achieved this end point and try to walk backwards to your starting point and make a design in this way. So you first focus or imagine like your application is already or your decision already made, and when the application or decision made, normally it starts with a press release or something like you already imagine that you made it. Now you should tell to your customers or to users or to developers, no matter what you call customers, what you done, what you achieved. So you start with the endpoint. In the case, or in the question of scaling, you start like you say, okay, our app now can handle 100 more customers if needed without need any rewriting any code. So you imagine like you already achieved this point. Next, you think about what is the customer experience. How do they feel it? So the answer to the question, or what you can write into a customer experience paragraph, is that our customers shouldn't be affected by the number of other customers are using. That's actually what I expected by customers. They don't, as I already mentioned, they don't care about the technical solution, how many developers are working, what is the support line, and so on. They just want to use your product, and no matter of other users. Okay, so another step when you're working backwards is to think about alternatives on options. It's very important. Sometimes when you make a decision, you think that you already have a best option. You already read a couple of articles from a very smart people who say you should use microservices. It's currently the best option that can ever be, and there's something that on the edge right now. But actually, the very important is to stop and try to come out with one more, two more alternatives or other options that, and then write pros and cons for each options. That's very important. So, for example, in Amazon, when you write this kind of design documents, if you don't have any alternatives or you have only one, that's a very bad sign, and it's good to iterate more to try to find this alternative. So for about the scaling, what options do we have? The first, if we have just service, we can just replicate it, and okay, previously it was okay for 100 customers. After replication, it should theoretically be able to serve 200, and so on. Quite often it's a really good decision, and that's what sometimes called also monolithic services. With the monolithic services, what you can have is you don't need a lot of changes of your system. Only think about the scaling persistence, so it comes up with minimal changes of the code. Also, your system is represented as a single monolithic application. So it's much easier to handle all dependencies inside of it. If you change something, you immediately see if other bits of the system compiling, and you can run tests. So it's still monolithic and very easy to test, to make some changes, and to maintain this kind of code. But of course, there's a lot of cons of this. For example, if you have different several instances of your service, you need to think about how they share data, and it's one of the serious problem. Also, if you have an application that serve all possible activities, quite often only some part of these activities are used often. Some other are used rarely. For example, if the application have a lot of read requests and not a lot of modification requests, but you still scale the whole application, including read and write parts. In a monolithic approach, it's quite you cannot scale differently this application, parts of the application based on the usages. Another approach or option is to use a microservice principle. The microservice is then when you break your application into smaller pieces, each of them are executing some very well-defined functionality or activity. And very important that each of these microservices has enough data to do this work without relying on other applications. Yeah, they can do it incorrectly. They can work on a stale data, but still they should be able to do this. And of course, they should have understand how to connect to other servers, how to communicate with them. With this option, we have, of course, a very good pros that we can scale it independently. We can do A/B testing. We can have different versions of one functionality working with the same version of another part of the system, and you can experiment and have, for example, 20% of users using new approach and 80% still previous, and had some statistics and feedbacks from users. But there is quite a lot of cons of this solution. You should the overall operational load becomes much harder because you need to track dependencies. You need to think about the communication between these microservices. Should they do asynchronous calls? Should they do synchronous call? Also, you have to think about the deployments and again, dependencies between different deployment versions. And the monitoring becomes really hard because you have different monitors for different microservices and they have different versions, so it's quite hard to implement, though it's possible. And the third approach is called serverless, where you can just delegate some parts of your system to the service provider that currently calls this function as a service. So you just have some code, you tell to Google, to Amazon, or to Microsoft, execute it when I need it. That could be, for example, when you upload new photo and you need to gather some information or resize it. It's like a typical application. So with this solution, you have really good pros that you don't have operational overhead. Normally, these platforms that provide the functional as a service, they have already well-defined deployment strategy, versioning. You can roll back very quickly, and most important, that you pay only for the execution of the function. You don't pay normally. You don't pay or mostly pay nothing for when nobody is using this specific functionality. So you have very fine granular pricing strategy. However, this solution have a lot of very serious cons. It has when you start deploying your function to this platform provider, you're really limited to the functionality that this platform provider provides for you. Also, these functions are usually stateless. That means that they cannot store some information locally like you do with the normal services or microservices. So you need to design serverless or stateless functions. Also, when you try to develop this offline, all of this functional service providers, they have some tooling, but still they cannot guarantee that the functionality that you have locally in your local development machine would be the same that when you deploy it. They try to be as close as possible, but still it's not always achievable. And also you need to think about the security of the securing endpoints, securing invocations of this service. So there could be some other options, but very interesting that all of these options still need something common. And this common, that's I will list. It's like a checklist of what you should always consider or should you check before launching your application? It's actually about 11 points, but all of them you should at least consider. Say, for example, this point is not relevant, but you should not skip it. Okay. The first, it's about you should define the vision of your system. What customers need. In one of the first principles in Amazon is a customer obsession. You should not. It's very you as an engineer sometimes are trying to find the most technically good solution. That you try to find the best, I don't know, version of language, or you think about should we use Java, Go, maybe C++ because we need high latency. But sometimes you can even use, I don't know, PHP just to provide what customers are needed. So that's very important to understand. And then this second part of this general part is to think about what are main activities that your user will do, and then immediately start defining the SLAs for them. Start defining what for acceptable for users, because if user tell to Alexa, hey Alexa, what current time? If it will be a couple of minutes, this answer will be not relevant. It's just a small example. So you need to define these SLAs before going further, before thinking about what the limitation of the platform, what latency of cloud provider, and so on. So think about the customers first. Then you need to identify the risk. What are operational risks? What can happen bad, wrong? And what when you make some decision, what you're making some trade-offs. So you think, okay, we will use this, but not this because of something. So you think you should think about what you're losing when you're making some decision. And then when you're defining this scalable system, you should think about how to minimize the number of users that can be affected if some parts of the system fails. So you should think about how to minimize. There are some approaches of this is to using the some sharding base of customers ID or user availability zones and so on. So, but this is a very important question. The next section, it's about the backups. Sounds like a very obvious one. We need just backups. And a lot of people just enable some checkbox, okay, enable backupping. But not always people actually test restoring procedures. And one of the recommendations is before launch, delete all your data. Absolutely, completely. And then restore it from the backup. Do it at least once before start. Because even if theoretically everything can go right, but in the practice, it's not working. And after launch, do it sometimes as well. Maybe not on a production database, but something very close to production. Delete everything and restore. Measures the time that was used during the restore. Know this data and use it for communicating with customers and so on. It's very important for when you're designing the scalable system to have this communication, but it will be covered on some of the next. Another question is to use or not to use auto-scaling. Actually, auto-scaling sounds very good. The system scales up, down, but there are some of the points that you should consider. For example, is it scaling good enough up, or if your system just failed, it starts downscaling, and even if you fix the problem, it's still not scaled good enough. Other question to answer about the retries. What is define your retry policy? What your customers expect, and what what policy of retries for your downstream, for example, for database or other services. The big point, and it's very important, is to have a right monitoring system. Unfortunately, I don't have a lot of time to dive deep into this section. And as already mentioned, this presentation is available in GitHub online, and I highly advise you to check and use these items as a checklist. Do I have throttling, monitoring? Do I have a latency, and so on and so on? Of course, logging. That's really important, because quite often during development you do a lot of logging, not important things, and when something happen, you start diving into this huge amount on logs. Unfortunately, quite often these not important logs takes a lot of time to process, and your recovery time extending a lot because of this. Of course, there's like a golden rule: never use exceptions for business logic. So exception is something that your system really behaves exceptionally, not good. Another point is about the planning capacity. You should think about what is the target number of users, number of connections, what resources you need, and try to order these resources before that. Don't think that if you want to pay, if I have $100, if you pay to Google or Amazon, they immediately provide these resources. Unfortunately, it's not working as this. Sometimes for example, if you're launching some marketing program, you can have a really huge spike that you can actually think about this beforehand, and you can order some hardware before actually starting this SMM program. Testing is, of course, another check point that you should always have. You should not do some obvious things like end-to-end testing, integration testing, but also you should track freshness of your data. How, if you have some unit tests, are they still what users are using? Quite often after a couple of months or half a year, this data becomes irrelevant. And during the testing, try to break your system completely. Make it down. Of course, not production, but and know when it breaks down. What happened? How latency starts growing? What happened with your downstream dependencies? What with database and so on? So it's very important before launch and after launch, but not in the production, to break the system regularly. These breaking points are very important during the scaling. This very obvious checkpoint, try to automate everything. If you have some manual action, describe them and explain why they're needed. Of course, it's not possible to automate. It's like in the ideal world, we have everything automated. In real life, we still have some manual action, but you should have them documented and explained why you need it. Maybe sometime later, some of these reasons becomes irrelevant, and you can reconsider and try to automate them. And last point, but not least, this about the communication. Very often, especially startups, launch their system, launch their service, and think, okay, we're done. We already have users and so on. But when something goes wrong, the users just don't know what to do. It starts, and you can lose your customers if you don't provide the good communication channels for them, so they can express their pain, and you can tell that, yeah, I know it. We are working on this. Unfortunately, sometimes that happens that people start using that, have some latency problem, and they just don't know what to do next, or something can fail and just give up using this application. So this point that very often missed, but it's really important. Gathering feedbacks, of course, that's obviously, and try to find and to make clear to your customers what ticketing system, what is a policy. For example, provide some more simple SLAs. For example, if you post some feedback or some trouble ticket, that we will react it during this X amount of time. We will have escalation with more Y days, for example, and you definitely will have some feedback after that days. So this is major points or major checkpoints that you need to think about when you're designing the communication system. And if you done this right, your application should be scalable, not only for the technical things, but also for the number of customers, number of users, so you can raise your audience much easier, not just number of transactions per seconds. So thank you for your attention. There is a link on my website where you can find link to GitHub, where you can find this presentation online. Small little quest for you if you're interested on this more details or item that I briefly skipped.